Hello my dear students, welcome to CR Digital Classes. Today we are talking about recursion with an example. Okay, so now we'll talk about recursion. What is recursion? Recursion is nothing but here where a task is divided and it is called n number of times. So once it is done, you are executing it and you are completing its work. So a task is divided into simplified tasks. So recursively we are repeating a particular task until the condition is satisfied. Once the condition is satisfied, you are executing and coming out of the particular statement. Okay, so here recursion statements in C are an easily available techniques which are given for the user, where it divides the complex work into simplified tasks. Now the key components of your recursion would be the base case and the recursive case. What is a base case and what is a recursive case? When you talk about the base case, it is nothing but a condition which helps the recursion to stop. So a condition which helps the recursion to stop is nothing but it is a limiting point. When you talk about the recursive case, it is nothing but a recursive functions call with a modified parameters based on the given value. Okay, now when you talk about the recursion, if you can check it here, we are calculating the factorial of a given number using recursion. Okay, now here what you are doing, you are entering a particular value, that is here num value is entered. The function is starting from the main. Okay, this is your main. Okay, the controlling factor is within the main. So main is said to be as a calling function, and here the factorial is the called function. Okay, now what you are doing here, we are entering a value, that is here I am entering the value 1. Right now I am entering the value as 1. Okay, now here 1 is sent as a argument, and it is sent, it is going and locating the particular area where exactly your body of the function is mentioned. So here it is 1. So 1, that is n is equal to 0 here. So here when you are n is 1 here, that is it is not correct, that is 1 is equal to 0 is not correct. So what you are doing is you are going and executing the else block, that is 1 into 1 factor, that is factor of 1 minus 1 is nothing but here you are not having a best recursive case, but you are having a value called 1. Factorial is always 1 only, so you are executing the 1. Now when you talk about n value as 0, then what happens is it is a limiting point and you are returning 1 and you are coming out of the particular program. Now what comes is when you talk about n value as 2. Okay, n value as 2, that is 2 into factorial of 2 minus 1, that is 2 into 2 minus 1, it is 1. So 1 into 2 it is 2, 2 factorial is always 2, you are getting the 2 factorial as 2. Now when you talk about 3, when you are executing the n value as 3, okay, now what happens, this case is not correct. Okay, what you are doing here is nothing but, okay, now the value now is 3. Okay, now what you are doing here, 3. So 3, n is equal to 3, 3 is equal to 3 is wrong. So this block is not executed. The else block will be executed. That is here, that is 3 into, okay, now you are getting, that is 3 minus, that is 1 again, n minus 1, n minus 2, like this is goes on till you are encountering with the value. Okay, now here 3 into 2 minus, that is 3 minus 1, it is 2. Okay, so here 3 into 2 it is nothing but 6. So here when coming around to, again you are executing the n value, your value is n minus 1, again it is decremented to 1. Then you are checking the factorial, it is 2 minus 1, it is 1. So again 6, it is the previous value which was holding. So now you are able to get the value as 3 is 6. So 3 into 1, 3 factorial is nothing but 6. Now next is when you are entering the value called 5. What happens is when you talk about 5, it is 5 into 4 into 3 into 2 into 1. So what you are doing is factorial of this particular is calling itself again n number of times, and it executes certainly when it is reaching a particular point and it executes the value, that is 5 into factorial of 4 minus 1, again it recursively calls the factorial n, again the value is 4 minus 1, it is again calling and it is replacing the previous multiplicative value. It goes on until it reaches a particular point, that is 4 minus 1, again 3, 3 minus 1, 2, like this it sums up and it multiplies its value until you get a final output, that is 5 factorial is 120. So in the recursive case, what happens is the value is multiplied n number of times till it reaches or encounters with the given condition. Once a condition is false, it comes out of the particular loop. Okay, so here when we talk about the recursive, here what happens is the value gets simplified and the task is simplified and you get executed. Now what is Fibonacci series? We'll take another example where we talk about the Fibonacci series. What is Fibonacci series is, that is here we are getting the series, that is 0 plus 1 it is 1, 1 plus 1 it is 2, 2 plus 1 it is, that is 1 plus 1 it is 2, 2 plus 1 it is 3 and 3 plus 2 it is 5. Like that the series goes on till your number of values are entered. Here the number of values are 5, that is why it is 0, 1, 2, 3, 4 and 5 value, that is here the values are incremented. Okay, now if you can check it here, I am executing the Fibonacci series. Now here it is checking with the Fibonacci value, that is again it is going and checking with the condition. Now here the value is int, I value is passed over there. Now the previous value n is less than or equal to 1, that is 1 is less than, if I am taking the Fibonacci value as 1, so 1 is less than or equal to 1, it is nothing but it is returning 1 and leaving the system. Otherwise you have the Fibonacci series where you are adding n minus 1 and again you are taking the Fibonacci as n minus 2. Like this it goes on till you encounter the loop. Okay, we'll see it with an example, then you can, it will be more proper for you. So what are the advantages of recursion would be, that is when you talk about the advantages, the complexity of the program is divided into simplified tasks and it provides a easy way where you can easily solve the complex problems like complex algorithms like GFS and Towers of Hanai or BFS. It helps us to consume more amount of memory because we need to maintain the state of the function calls rather than the value. So and here it can lead to stack overflow because if the base is not handled correctly, it will lead to the errors. So the recursion has its own problems and we can use recursion when the problem naturally breaks down into smaller part. But when we talk about the Fibonacci series or the factorial or the tree traversal, basically these are the three areas where exactly we use the recursion. So these are the things which we take it in the recursion. The advantages is, that is it is easy and sub problems are divided into sub problem, but it involves more number of memory due to the headaches of keeping track about the function call, which we need to maintain the state of the function calls. So these are the advantages and disadvantages of recursion. So here the summary points would be, the best case or the base case stops the recursion, whereas recursive case executes the function. And recursion is always a technique where it involves a function to divide its work into simplified tasks and it helps us to solve the complex problems easily. So these are the key points of your recursion. If you like it, please like and subscribe to the CR Digital classes. We'll see with an example at the later stage. Okay, thank you so much.